Friends, so let us discuss about the spectral properties of hexa aqua titanium 3 ion. So in hexa aqua titanium 3 ion, the titanium ion is in +3 oxidation state and it is surrounded by 6 aqua ligands, that is water ligands. So hence the coordination number of the titanium is 6 and it has the octahedral geometry. So we know that according to the crystal field theory, the d orbitals of the titanium ion contains 1 electron. That is, 1 electron will be present in the d orbital of the titanium. So therefore in ground state, that 1 electron will going to occupy the lower energy T2G orbital, and the energy gap between the T2G and EG orbitals is very low, so that the 1 electron which is present in the T2G orbital absorbs the radiation in the green and yellow region around the 20,300 per centimeter wave number or 493 nanometers wavelength. So the energy corresponding to this radiation is calculated by using the formula. So that is Hc divided by lambda. So that is equal to 243 kilojoules per mole. So this energy, that is the octahedral complex, and the T2G electron excite to one of the higher energy levels, that is EG orbital. Okay, so when the D1 electron present in the titanium ion absorbs an energy of 493 nanometers, the electron will be excited into the higher energy EG orbital. So as a result, the solution of the complex will appear purple, so which is the complementary color of the absorbed radiations. So this can be explained by the diagram. So here you can see in the titanium ion, so the D1 electron is present in the lower energy T2G orbital. So in the presence of H2O ligands, so the degenerate d orbitals will split into the two sets of energy levels, that is T2G and EG. So the electron will occupy the lower energy, that electron will be present in the lower energy T2G orbital. So when that titanium ion absorbs the radiation, so the electron present in the lower energy T2G orbital will be excited into the higher energy EG orbital. So here you can see the absorption spectrum of hexa aqua titanium 3 ion. So next we shall move on to the one more complex ion, so that is hexa aqua cobalt 3 ion. So in case of the hexa aqua cobalt 2 ion, so the cobalt is in +2 oxidation state and it is surrounded by the 6 water ligands. So hence the coordination number will be 6 and the geometry will be octahedral. So according to the crystal field theory, so the d orbitals of cobalt in +2 oxidation state contains 7 electrons. So that is, it is having electronic configuration of D7, and water being the weak field ligands. So the out of 7 electrons, so the 6 electrons will occupy the lower energy T2G orbitals, so with the pairing, and remaining 1 electron will going to occupy the higher energy EG orbital. Okay, so the energy gap between the T2G and EG orbitals is very low, so that the absorption bands have been observed at 8,350 per centimeter and 19,000 per centimeter. So the energy has been calculated at the 9,000 per cm per centimeter. So using the formula, that is Hc by lambda, and it is equal to 107.65 kilojoules per mole. So this energy, so that is octahedral for octahedral complex, and the T2g electron excite to each of Eg orbital. So as a result, the solution of this complex will appear blue in color, that is complementary color of the absorbed radiation. So as you can see in this diagram, the cobalt ion, the 7 electrons are present in the d orbital, that is d7 electronic configuration. So in presence of ligands, so the degenerate d orbitals will split into two sets of energy levels, that is T2g and Eg. So the out of 7 electrons, so the 6 electrons will occupy the lower energy T2g orbital, and the remaining 1 electron will occupy the higher energy Eg orbital. So when this titanium cobalt absorbs the radiation from red and purple region, so the electrons in the lower energy orbital, so out of the 6 electrons which are present in the T2g orbital, so the 2 electrons will get excited into the higher energy Eg orbital. So therefore in the complex, so the cobalt in the excited state, okay, so 4 electrons will be present in the lower energy T2g orbital, and 3 electrons will be present in the higher energy Eg orbital. So as a result, the complex will appear pink in color. So here you can see the visible absorption spectrum of hexa aqua cobalt to ion. So you can observe the two peaks, okay, at 8350 per centimeter and 19,000 per centimeter. So that shows the excitation of the 2 electrons from the lower energy T2g orbital to the higher energy Eg orbital. So next we shall move on to the one more complex ion, so that is tetrachlorocobalt 2 ion. So in case of the tetrachlorocobalt 2 ion, the cobalt is in +2 oxidation state and it is surrounded by 4 chloro ligands. So hence its coordination number is 4 and it has the tetrahedral geometry. So we know that according to crystal field theory, the d orbitals of cobalt in the +2 oxidation state contains 7 electrons, that is d7 electronic configuration, and the chloro ligand, so is the strong field ligand, okay. So therefore the out of 7 electrons, the 4 electrons will occupy the lower energy, that is a T2g orbital with pairing, and the remaining 1 electron in case of the tetrahedral complex. So in case of tetrahedral complex, the 4 electrons will occupy the lower energy Eg orbital. So in case of octahedral complex, the lower energy orbital will be T2g, but in case of tetrahedral geometry, so the lower energy orbital will be Eg. So therefore the cobalt ion having the d7 electronic configuration or containing 7 electrons in the d orbital, okay. So out of 7 electrons, the 4 electrons will occupy the lower energy Eg orbital with pairing. The remaining 1 electron will occupy the higher energy T2g orbital. So the energy gap between the Eg and T2g orbitals are very low. So this absorbs the radiations, that is 3500 per centimeter and 6300 per centimeter energy, and that energy can be calculated by using the formula Hc by lambda, and it is equal to 37.1 kilojoules per mole, okay. So as a result, the solution of this complex appears blue, so which is complementary to the absorbed radiations. So as you can see in this diagram, so the cobalt in +2 oxidation state having the 7 electrons in the d orbital. So under the influence of the ligand, so the degenerate d orbitals will split up into two sets of energy levels in case of octahedral geometry. So that is lower energy Eg orbitals containing 2 orbitals, and the higher energy T2G orbital containing 3 orbitals. So when this cobalt 2 plus ion absorbs the radiation from the red region, okay, so the chloro ligands being the strong ligands, so the unpaired electrons will get paired up in the Eg orbital. Okay, so the 2 electrons from the lower energy Eg orbital will be promoted to the higher energy T2G orbital. So you can see here the visible absorption spectra of cobalt 2 plus 2 ion. So you can observe 2 bands. So one band at 3500 per centimeter and another one is 6300 per centimeter. So these 2 bands indicates the excitation of the 2 electrons from the lower energy Eg orbital to the higher energy T2G orbital.